I don't care if you're sick of this slide. Do it. This is important. All right, my name is Grant Fritchey. I work for Redgate Software. We're the intimidating tower of awesomeness downstairs. Feel free to stop by. It's not intimidating. It's welcoming. We're happy to see you. But this is my email address, my Twitter handles, all that other stuff. I want to help. If you've got questions, send them. I like to help out. So I do this every session. I probably teach 50,000 people a year or something. I forget. I couldn't tell you. A lot. I get like 3 emails a month, maybe. Feel free to use it. This is an open, direct, personal invite. And I don't do about me slides because nobody cares. Right? So let's talk. Session goals are simple. At the end, I'm going to show you something wicked, cool, and new. But before that, we're going to talk about containers. I want to try to explain to you what they are. I also want to explain to you how I think they're going to change the way you do development and testing. And I really, really focus on the way they're going to change development and testing, not because they're not possibly going to change the way you do production. They may. I mean, sitting in the back of the room is the person who has taught me everything I know about containers. So Anthony Nocentino's hiding back there, trying not to get noticed, but too late. Wave. Wave hi. Yeah, okay, there you go. Isn't that cool? He does what I say. That's awesome. Yeah, like that matters. Anyway, when you're ready to go deeper than what I'm going to do for you today, talk to him. He's going to help you out, I promise. But I'm going to talk to you mainly about development and testing and all your non-production environments, because I think that this should fundamentally shift what you do, just right out of the gate. Who here downloaded the newly released, just available SQL Server 2019? Anybody? Yeah, cool. How long did that take? Not long enough. How long did the download take? I spun up a container with it in about what? 45 seconds? 45 seconds. Done. It was brand spanking new, just out. Here it is. Yay, you got it. Boom, it's up. Containers are magic. They are cool. So let's get going on them. Let's talk about what they are. We'll talk about what they are. We're also going to talk about what they're not, because it gets a little sketchy. They're sometimes hard to understand. I had a hard time understanding them. I also had a very hard time understanding just how bloody wonderful they are. That was my big thing. So a container is really simple to explain, right? It's an application and all the crap needed to run it in an immutable form. You define a container, you define an image, actually, and then it becomes a single executable object. And whatever that application is, and in our magic case, what are we excited about? SQL Server! Yay! Although usually when I do this session, I will demo with Postgres containers, believe it or not, just because I can. And it also gives me an excuse to fire up Azure Data Studio, which I like playing with, which we'll be using today, because it does also work with SQL Server. But it's just a single immutable executable that you can run wherever. You do have to have a container management service to run them. Yeah, that has to happen, right? And what's the one that everybody's going to use, although we were talking earlier about it, the fact that they're bankrupt, but Docker. They're the big kid on the block. They're what everybody's using, so that's what we're going to use. But anyway, we'll talk about that in some more detail. But you've got to have that management tool. But then once you've got that, you've got this thing. It's an executable, and it just runs. And it doesn't matter your operating system. It doesn't matter its operating system. And that's one of the things that people say, look, well, God, all the containers are all on Linux, and I want to run containers on Windows. It's like, well, it kind of doesn't matter because what's the important part is it's SQL Server delivering, 98% of its functionality, whatever it is that they support inside of Linux. And I know that the surface area is a little reduced, but it's reduced in areas that you shouldn't be using it anyway, so it's all fine. That's what a container is. Now, what a container is not. Even though containers are using virtualization, they are built off of the concepts that the virtual machine systems first gave us back in 03, 04. Who else is old? So I'm seeing a lot of youngsters in the room. My God, who let you guys in? Anyway, a container is not a virtual machine, even though it's using virtualization technology. So you must have a hypervisor for it to run on. It has to happen. It has to have a hypervisor. It has to have the hypervisor, and it has to have the container management systems, such as Docker, and there are others, but the only one anybody's going to use. It's also not simply an application. It's not just an app, because these things are weird and wild. They do cool stuff. The fact that you can spin up an instance of SQL Server in 45 seconds, I don't care how fast you click next, 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 okay. It's not going to take you 45 seconds to get a version of SQL Server online. It just won't work. You can't do it. So these things are wildly different than the stuff we're used to doing. And did I mention small? Tiny and fast. Now, when I talk about dev, and I talk about DevOps, and I talk about dev automation, and provisioning, and getting people all moved into development and all that fun stuff, what's the one thing we want? Speed. And I want it on my laptop. And I don't want to have to build a virtual machine and all that big fat thing using up all the memory and all that. I want it fast, and I want it now, and I want it on my laptop, because my laptop doesn't have very much storage. I've only got 500 gigs in the Surface Book. And that's the big Surface Book, right? 500 gigs. But I want to do development on it. Containers make that happen because they're tiny. Now, can you make a container big? Sure. Why would you shoot yourself in the foot? It's choice. You can, right? Boom. But it's not going to be good. So how containers work is pretty simple. You've got the hardware, whatever hardware you're running on. Cool, we got that. You've got the operating system, whatever operating system you're running on. Yay, right? That has to happen. And then we've got the container management software. Now mine is using Hyper-V locally. I'm not going to be demoing my local stuff today, but it's using Hyper-V and Docker. Hyper-V is the hypervisor, and Docker is the container management software. But then after that, it's just a stack of containers on top. Spin them up, spin them down. You can control them, you can manipulate them, and if we're talking SQL Server, you can get and have fun and start giving them virtual CPUs, set up their memory, manage the disk, all kinds of crazy stuff. But it's pretty simple to understand. It's just not hard what they do and what they are. Any questions so far? And I didn't mention this. Shout out questions, shout out comments, play Stump the Chump. I've got Anthony in the room, so I'm just totally relaxed that I will have answers. I know everything now because he's here. Hyper-V is not an operating system, but it's part of the necessary stuff for the container management system.
What's your operating system?
This one I'm running Windows 10. Oh, I'm sorry, I didn't mention that. Yeah, you're right. I'm running Windows 10. It doesn't have to be Windows 10. I've got a system at home running Linux, and I do this exact same demos on that, just because I can. It's all Linux, and I can run it the same way. And it uses a different hypervisor at that point. It's not Hyper-V anymore, but it's all cool. Yes. Docker is open source, so it's free. Okay, so let's talk open source for 1 second, real quick. Who says open source is free? Few people. So open source, almost every open source software has a free tier. And then, like, for example, MySQL, and I found this out only a year ago. I don't know why it took me so long to find out, because I would have loved to have known this longer so I could be more angry. If you want to do, I don't know, something like hot backups, backup database while it's online. Backups, mind you, you can't do a data export anytime you want, but if you want a backup, you know what you have to do? Pay for it. At which point, dun-da-da-da, it's useless as free. It's not free anymore. It's a licensed software just like everything else. But yeah, it's free. It's totally free. We'll talk about Docker some more. Now, images are a file, right? It's a single file. When you get them, it's one file. That's what makes it cool, because you download the image, and it's a file. And you get an image, say, of SQL Server, and it's this thing, it's all the code, it's all that stuff that has to define it, any of the drivers needed, anything from whatever OS you define that image from. If you define the image, you just might be consuming stuff. But whatever you needed to make that app work, just the stuff that's needed, just the bits and pieces and bobs at the edge, all of that stuff comes in and it's all on one file. And so we get that one file, it's all it is. And that's our image. Now the image can't be changed. The image is sacrosanct. When you get an image, it's the image. It's the full little executable, and that's all it is. That's all you can do with it. And each image has a base, and the base is an OS. It's an operating system it has to have underneath it, but it only pulls the bits of the operating system it has to have. But each image is also a base. And what you can do is add a layer to your image. In other words, you can get an image, not modify the image, but put some stuff on top of it and create a new image. So for example, if you want to do something crazy, again, make your big fat image, which don't do this, but you can. I tested it because I'm stupid. You can grab an image and spin up a clone, or not a clone, sorry. Spin up a container from the image, stuff it full of data, and then create an image from it. And then you've got this like 40 gigabyte image that no one wants anymore. But you can then create containers from that image. So you can do these, and the way it works is images are immutable. You have to create a container. You can then make changes to the container, and then after you make the changes to the container, you can make a new image, and that new image is immutable. And you can just build them up as you need to. So why would you do something like that? Well, it's simple. Let's say you're looking at a default instance of SQL Server. You go and get the image from Microsoft, you download it. Cool, I've got it running. What's the cost threshold for parallelism on that instance? 5. Stupidest default ever. Cool. Spin up a clone, change the default, create a new image. Now, when I create containers from that image, guess what? I've got a real number. So you can make changes like that. I mean, that's a trivial example, but it gives you an idea of what the kind of stuff you can do with it. Everybody cool with that? Any questions on any of that? Yes?
So I could take the base image, modify it, create a new image.
Can't modify the image. You can, yeah.
And add to it.
Right, add to it, right.
Create a new image. How can I create the base image?
Well, I mean, you can just go and you can fire up Docker and say, here's my OS, create an image. But what you've got, there's a whole bunch of technology around that. I'm kind of focused on the way SQL Server and SQL Server images work, but there's a lot of documentation. Anthony, you have a preferred? He wants to just start with nothing and build an image.
So a lot of times you'll find the Docker file and start at a relative point in your file system forward.
Right.
Information into,
Yeah, you basically, you can send Docker commands to say, like, this is the point of my operating system to start from, and send this into the container image. You can do it that way.
This is files and executables.
Right, yeah, because it's all down to you're supposed to be focusing on an application. So you want to build it from some given app, such as, thank you. God, that was an easy one. Come on. SQL Server, yes.
If you're using Windows as the base image in SQL, how does licensing work with that?
Do I look like I work for Microsoft? The question was, hey, what's my licensing costs on this stuff? I'm like, I don't know. For development, it's free. Yeah, quotes. I agree. For quotes. But for if you're getting into production stuff, it's varied. Microsoft has a whole bunch of documentation on the licensing around containers. Go read that, sir.
Any pros or cons for creating, starting that base image, making your change from your cost threshold, or adding it as a layer?
Well, when you make the change and create that new image, you are adding it as a layer. That's what you've done, because the original image is immutable. You've put some changes on top of an immutable layer. They're kind of, this is where containers get weird. Yeah, it kind of, there's multiple commands, and the multiple commands can make layers, but the easiest way to think about it is that when as you create a new image, you're creating layers on top of an existing image. That's the easiest way to think about it. It's the easiest way to make it work. Yeah.
Does that mean when you're going between different, like cumulative updates or something like that for SQL, do you have to make a new image?
So if you're doing cumulative updates between SQL, do you make a new image? No, I would just go to Microsoft and download them. I mean, as they've gone through all the RTMs on SQL Server in 2019, I would just go in. It's really fun when you start doing if you're just doing straight Docker, right? Not doing anything through Kubernetes and all that crazy stuff. If you're just doing straight Docker, you can go in and issue a command and say, like, give me the latest. But you can also say, no, I want this one. I want the last CU. I want and you can pick and choose which one you want.
So then if you have an image, you've made a bunch of layers on it and made a new image.
Right. Yeah. Then if Microsoft releases a new version, but you want to you're going to have to you've got work in front of you. Yay. Yeah. Nothing magical here. Also, a thing to remember, I haven't brought this up yet. Containers should be short-lived. You shouldn't be spinning up, I've got my container here, I'm going to run for the next 6 years. No. 6 days, 6 hours, right? It should be short. Yes? Is there any way to spin up volumes along with a container? Yes, we haven't gotten to that far. You're racing ahead of us, but absolutely there's a way to spin up volumes. Is everybody cool with images? Because that's where we start. The easiest way to do this is just go and download one from Microsoft. And literally you don't have to do anything else. Yes?
Why should they be software? Because for SQL, my users want
Okay, well,
not for 6 hours.
I'm primarily talking about production. I'm sorry, development, not production. If you want to really see how production containers work, and there are containers in production, you also then want to be talking about Kubernetes, because they're doing this whole management thing with containers, and I'm going to talk about it very little. I'm going to gloss a bit on Kubernetes, but that's where you're going to head. And yes, of course, that's going to extend the life, but it also kind of doesn't. That's a whole different discussion. Talk to him. They're amazing and magical. It's wild stuff. So let's start talking about what we do to build containers. Now, I've already said it, but I like to say it again because it's really important. If you want to spin up the container freaks online, just say, it's just like a VM. Because it makes them insane. But I'm feeding that to you so you know that you're going to make them crazy. Because it is not a virtual machine. It is totally different, very much different. But it's an execution of an image. That's what a container is. You've defined your image, or you've downloaded your image, and then you execute that image. It's a container. But here's the fun thing. You can execute it multiple times. You can spin up multiple containers. You're not doing anything to that image. The image is just sort of a foundation for the behavior of the container. But the container is this virtual magic bit, and it's running off the image, but it's totally able, you can do more than one. Now, each container, we've said it several times, but I like to repeat myself sometimes to make sure things are clear. Each container is based off an application. Could you stuff the planet into an image and spin up containers from it? Yes. Why on earth will you go through the labor to recreate virtual machines? If you want a virtual machine, we got those. Spin that up and use it. But this is based on the idea of application-specific behaviors. So we want an app. Again, in our case, we're talking about SQL Server, right? Also remember that containers can be changed. As we said earlier, images are immutable, but you can create your own images by getting an image, creating a container, changing it, and then creating an image from that. Everybody cool? So we're good on what an image is and a container. And it's fun because we always talk, everybody talks container, 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 container. But you know what you're really doing? Images. I don't know why this one's the magic one but this is doing all the work. You got a clue? I don't know, but that's what's happening. There's magic in the image, and then you're executing that to have containers, but this is what we talk about. I don't know why. Maybe images just didn't sound cool. I don't know. So, you can do your own images, right? You absolutely can. You take a base image at the OS, modify it as necessary, create new images, then create containers, and then you can deploy to the containers. You can do whatever you want. I am focused on these things as development tools, as testing tools, because I think this is where the easy magic comes from. Could each and all of you run this stuff in production? Sure. I mean, you're definitely going to want to talk to the Kubernetes people and figure all that stuff out, because it is a management nightmare if you're trying to do this by hand. But from a coding standpoint, from a development standpoint, a couple of PowerShell commands, and bam, you guys are running. It's easy, right? It's just easy. So this is why I focus on being development. Now, stepping away from simple stuff, stepping away from the simple ideas, Docker run, right? Because that's our magic. Docker run is all we need. We've got these things called orchestration. Now, this is Kubernetes. This is where we would start talking about either very high-end development style work or services that do this kind of thing. But regardless, the idea here is that we're not talking command line automation anymore. You're talking about a massive service. I would recommend going with the online services, AWS, Azure, Google. There's a few others. Because what you've got is declarative configurations. You tell it what to do. You just straight up say, this is what I expect to see, and give me 100 of them. And zoom, off it goes, and you get them. It's pretty cool. You have to define rules and constraints, but it gives you a completely automated way to provision multiple servers very, 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 well, I say servers. My language is still bleeding around the edges. It's hard to remember that's, even though that's what we see, it's not what it is. Yeah, it's multiple containers, not servers. Also, the orchestration tools will give you monitoring for your containers. If you've got a vast sea of containers, you want to know if they're up or down. And it gives you all kinds of wild and amazing, and I mean amazing, clustering capabilities. Right? Grouping containers and moving them as groups, spinning them up, having failover type scenarios, all kinds of crazy stuff. That's later, right? You'll get to that. Now, if you're doing orchestrators, and I should take this off the slide because I've stopped saying it. I used to say it all the time. Kubernetes, everyone drink. Right? You know, it's not as funny anymore. Amazon ECS, they've got a great service. I'm actually going to be demoing Amazon ECS when we get to the demo part. Although I'm not going to show you Amazon ECS, I'm just going to use it. Guess what it's using? Kubernetes. Yeah, Kubernetes. Now there is Docker Swarm. Docker Swarm is also an online management system for orchestration. Guess what it's using? Kubernetes. Yeah, it's wild. Azure Container Services. Microsoft has built it into Azure. I've tested it a few times. It's working really good. You know what it's using? Kubernetes. Google Container Engine. Say, I don't even know what this is. Core OS Fleet is not using Kubernetes, unless I'm wrong. Anthony? Good. I don't even know what it is, but I had to find one that wasn't, so I could tell you that there is something beyond Kubernetes. I'm not a Kubernetes expert, but you could run it on other processes. So here's the idea. Containers are fast. Containers are tiny. They just fire up. You get the image, you run the container. So it's fast and it's easy. If we're doing development, I want to run it on that and I want it to be quick. So I can can my deployments. I write a couple of scripts and I can hand that script to my development team. And then I don't ever have to talk to them again. Totally kidding. If you're doing good DevOps, you're talking to them every day, all the time, sharing, doing good stuff. Who in here is a developer? We're not picking on you today. Or ever again. Well, okay, maybe in the SQL injection session. I'm not going to rant. Also, this gives us the capability because we can spin up environments really quickly. And yeah, you can think about it like an environment because it more or less is. Because we can spin up an environment really quickly, we get better testing. We get more thorough testing. Also, you create an image, you can give it to that weird Mac head in your office, right? The one, it's like, I have to have Macintosh or I can't work. Right? So, who's a Mac head? Come on. 2 hands. Anthony. Awesome. 3. There was 3. I don't care. I honestly don't care what my hardware is. Just make it work. I'm not a fan of the Mac, but I'm also not against it. But we've got full portability. Why? Because as long as we create, if we're using Docker as our management tool, or if we're using Kubernetes as our management tool, we create an image supported by Docker, supported by Kubernetes. It doesn't matter what OS it's running on. So we can create these things. And that's why you're going to see lots and lots and lots of Unix containers, Linux containers, right? Linux is going to be the OS for the container that you're probably going to use the most. Why? Because Windows is not really good at containers. It's kind of fat. And so it's actually bigger, a little bigger and a little slower, and it's kind of not great. Now, that for some of us, for a few of us, that's going to affect development, and that's going to affect some of our testing because we need Windows. Fine, go and get a Windows container, you can do it. But for the rest of us, most of us, the fact that it's Linux as the underlying stuff inside that container doesn't matter at all. Because what is a container? It's an executable that we're running and deploying. And what executable do we care about? SQL Server. Who cares that there's a little bit of underlying bits about Linux? I don't care. Except there's a few bits and bobs at the edge that we would care about. Like I said, some of us aren't going to be able to do it, but most of us, no issues. It's just going to work. And frankly, it's consistent. Now, said nothing but nice things, right? Time to pick on them just a bit because there are constraints in containers. First up, security is a bit of a hassle with containers. Absolutely, if you're going through Kubernetes, there's ways to control it and ways to manage the security for production environments. You're set. But when we're talking dev and all this stuff, it gets really dicey running the container locally on your system. It's not necessarily going to hook into your security system well. You're trying to use a Windows login might not work because you're running on a Mac, or some of the other issues you could run into. There's security becomes a bit of an issue. If you need the full operating system, right? If you've got to have we also need and all these other things inside of my container. You don't need a container, you need a virtual machine. Go back to virtual machines. I mean, there's nothing, containers are not going to make virtual machines go away. This is not one of those, this is it, there's no more virtual machines, no more hardware, everything's magic now, it's all in containers. No. Different tools for the job, different behaviors require different tools. We're going to use the tool we need. But if you need an OS, you go with a VM. If you need the fastest possible execution, one, why are you doing that in dev? But two, containers may not be the magic bullet. If, again, we're talking about a single container. You're talking Kubernetes and configured, mass swarm container things where you're just throwing processing at the problem. Cool, it's going to be way fast. But if we're talking about a database running on a container and I'm running a query, ain't going to be that quick. It's actually a bit of a performance pop. There's adjustments you can make to make it a little faster, right? Give a little more memory. But overall, it's going to be a bit of a performance pop. So that's just something to know. For development, who cares if a query takes an extra 20 milliseconds, 50 milliseconds? Yeah, when I say performance pop, I'm not talking like, okay, normally we run the query, it's 5 milliseconds, but this is 20 minutes. No, I'm talking about it's a little, because they're going through these layers of virtualization and management, it's going to slow down querying a bit. But we're talking microseconds, milliseconds, not much. But it's something to know that it is a bit of a limitation. And then the big limitation, data. Data is a giant pain in the bottom when it comes to containers. I'm just stating it up front. Your pain is going to be the data, because you're running SQL Server and you're running SQL Server in development. And so what are we going to do? Well, we're taking the production database and giving it to every developer, right? No? There's one lady in the back going, yeah. She ain't happy about it, but she's, that's what's going on. We're going to give the development team data. We have to. They need it. They have to have it. No, it's not production. But what if you want to give them production size data? Or what if you want to give them half production size data? What if you want to give them more than can fit on my little 500 gig laptop? Crap. It gets hard. Okay, fine. So we say what we're going to do is we'll reduce the amount of data we're going to give them. Now what? Well, let's say it's small enough that it's going to fit on a laptop. Cool. We have options. You can spin up containers and then tell them, hey, you know what? That's a drive over there. And it's just a folder on your machine. But you tell the container that's a drive. Say, by the way, this is your drive. And then anything you drop into that folder on your local machine appears inside the container. Huh? Local drive inside the container. It's not a shared anything. Ultimately it is, right? It's sharing, what you're doing is using this natural disk virtualization thing to go over there and say, this is a folder locally running on my little OS, Windows, Linux, whatever, hooked to this container, and inside the container, whether it's Windows OS or whatever, it goes, hey, look, I have a drive. But instead, what it is just a local folder. Now, what could you do with that? Drop a backup in it. And then that means I can run the restore inside the container? Yay! Or drop an MDF in it. And then run an attach inside the container. And dun-da-da-da, you've got a database. Yay! But you only do it one container at a time. And they're all full-sized. So when you run the restore from your backup, how big's your restore? 200 gigs. How big's the database going to be approximately? I mean, depending, let's say there's not like just vast amounts of free space. Probably 200 gigs, give or take, right? So now we've got 400 gigs on my system. Oh, damn. So data is a bit of a management headache when it comes to containers. Again, unless we're talking about massive Kubernetes things, and then it becomes a different discussion. So this is my deal. I want my developers to have isolated SQL Server instances because I want them to burn the house down without affecting me. I'm lazy, and I'm very, very easily frustrated, and you guys do crazy stuff, and that's fine. It's part of development, but I want you to do it on your own. And I want it to be self-service because I want to talk to you. I'm joking, but I want it to be self-service because I want you to be able to run when you're ready to run. I'm a morning person. I'm hated by most of humanity. I will get up at 5 a.m. and I'm ready to go. My wife hates me. She tells friends, he gets up in the morning and he puts on his clothes before he does anything else. Yeah, I'm ready to go. But maybe but also, by the way, I'm usually done work around 3 o'clock. I'm out. Now I know other people, they roll in around noon. Oh God, I'm still here. But then they'll stay till 10 p.m. So I'm not supporting them after 3. They're on their own. So that's why I want this all to be self-service. But what we need is a fast way to give it to them. Containers are the magic. They can spin this stuff up all on their own. They can have it happen, and it happens fast, except for the data. And the data slows everything down. You can, I already said it, put files in the containers, and that makes the containers huge. You don't want to do that. You can do the link storage and do restores or attaches, figure out what you want, but it's still going to be big. You don't want to do that. And it slows everything down because you've either got a giant image, so it takes 25 minutes to spin something up, and that sucks, or you spin it up, and now you got to go run a restore. Nuts. So data is a problem. Oh, wait. What if somebody was to take a really cool tool called Sql Clone? Anybody ever heard of it? No? Okay, cool. No, that's all right. I want to tell you. Sql Clone is a Redgate tool. And this is the part we shift. Anybody wants to run away, you're free. Redgate tool that what it does is it has disk virtualization. And it's flippin' magic. Because what it does is you can create an image, use the term image again, these are overloaded terms, obviously. You create an image, and that image is your tax. It costs something. It takes storage. But you have to create one image. I mean, you can create more than one, but you have to create one. The image is the tax we pay. It takes about as long as a backup. It's about the same size as a backup. It's a page-by-page copy of your database. But you create one of those, and then you can create clones. Clone takes about 200 to 300 megabytes and is created in about 15 seconds, regardless of the size of the database. And we support up to 62 terabytes. You can create a 62 terabyte database in 15 seconds. across any multiple developer machines and all you want. And I'm telling you now, it's a technical preview, and hopefully it's going to all work. Fingers crossed. We got it working with containers. It wasn't working with containers before, but now it is. Now we got it working with containers. And further, right now, it's going to work with containers locally. It will work on Docker. You will be able to run it locally. But right now, we've got it working on Kubernetes. So it's all spun up online, all through the Amazon ECS. It's pretty cool. So what we've done is now, with this, we've unblocked this whole self-service problem inside of development. Because now, if you're trying to do containers in development, which I recommend, you can also do data quickly inside of the container. Ye flippin' ha. Because it's going to refresh these things in seconds. It's fast. Although my demo, I've already run it a couple of times, the turnaround time on the internet, stupid, horrible convention center internet. If only there was somebody we could talk to about it. I'm the past president. It was a joke. Good gosh. We can take terabyte databases, move them into megabytes, and then attach them into containers all in seconds. Woohoo, take my money! No, not yet. You want to see it probably. It's like, so the idea is that the data virtualization now, if you're talking about application virtualization, okay, containers is cool. We've got that covered. We're able to control it. But we're now able to virtualize data on the containers too. So now we're not talking about a slow process where we have to run the restores. We're not slowing things down for the provisioning. We are making it automated. And because we've got the Redgate tools plugged into it, all as part of our processing, we can do, along with building the clones, we can do data compliance. We can do data masking for your production systems. As you create your images, we will mask the data directly, and next either through our tool, Data Masker, or through your own T-SQL scripts. Either one. We can create that. We can create the masking as you create the image, and then you can consume the clones inside your containers. You don't know how long I've been yelling at my dev team. He knows how long I've been yelling at my dev team. But you've no idea just how much. And by the way, if you know Redgate, Steve Jones has been yelling at the dev team. And we got Kendra Little. She started yelling at me and Steve first. And then she started yelling at the dev team along with us. Once she yelled at us first because she's like, I need help. Because she's smarter than I am. She figured it all out way ahead of me. But that's what we've done. Now somebody had a question. Sir.
So what happens with the data that you change in the clone and when you shut down the container?
What happens to the data when you change the clone and you shut down the container? Nothing, because you've created an image inside of clone, and that image is still there. So the container goes away, the clone goes away, but the image is still there. You can still have that data because if you manipulate the data locally and then you shut down the clone, that data goes, the local manipulated data goes away. Oh yeah, by the way, did I tell you the database that we create from this thing? And I know you're already saying, well, gosh, it sounds like magic. It's fully readable, fully writable. But the writes are local. So if the first thing you do is, rebuild all the indexes on your database, guess what? You've more or less just rehydrated everything locally. So, it's on you. That's not my fault. Well, Grant, I don't have 62 terabytes of storage. Yeah, I know. That's going to be fun when it pops. So don't do that. But also because these things are intentionally meant for development. They are intentionally meant for testing. They are also intentionally meant to be short-lived. So hopefully, assuming you don't do anything crazy, it'll only be there. It'll only be a few hundred megabytes ever. And maybe a gig, 2 gigs, because you've manipulated some data. Yes?
Do you look at it as another layer, so you have your
Image.
along the bottom and all your clones?
I wish we could do that. She said, can we make it a layer inside the images? And we're not there yet. No, not yet. I think it's going to happen. Pretty sure it's going to happen, but it won't be there anytime real soon. And by the way, this is I said preview, didn't I? Okay, good. This is a preview. This ain't cooked. It ain't done. Regate prides itself on, what is that, ingeniously simple? It ain't ingeniously simple yet. It ain't even ingenious yet. So we got a little bit of work to do. But it's working. It's functional. We're there. Rough estimated timeline, I would say H1 to H2. And I lean towards the first. Yeah. I lean towards the first only because I can show it. Here, let's play a little bit. So, what I've got is a little PowerShell script that I meant to have open. Sorry. Let me just open it. Oh, God, I cannot see. Apologies. Blind old man. How are we doing on time? Oh, 30 minutes. Wow. Okay, I went a little too fast. Maybe giving you part of your day back. We'll see. Or not. Anybody cheering? No. We're going to... Anybody cheering? That's it. We're done. Let me find it. Can't even see it. Wow, I am old. Come on. Aha. All right, so what we've got is a little PowerShell script. Probably shouldn't be showing it to you because it's got my password in it, I think. So we've got a thing. It's going to take about a minute. So what we're doing right now is I'm just creating full-blown, I'm just going for creating 2 databases. But it's effectively, I'm spinning up an instance with databases and data. They're a few hundred megabytes, I think. Or no, I'm sorry, a few hundred gigabytes. They're not huge, but we wanted to have something up there just to show what's happening. Again, if you wanted to recreate those images, you would have to create them as they would be about the same size as your backups, but the clones are the magic bit. So this is going to go in and it's going to pull stuff out. It's going to run git clone instance, verify that if it's me, then it's going to git clone instance and starting create and pull them all back. It's going to pull back the listings. And then, oh wait, I'm looking at the wrong goofy thing. It's going to create a new clone instance database for one database. It's going to create a new clone instance database for the other database. And then it's going to create a new clone instance and pass both of them in to our new tool, and that spins up a container. We're going to find the container that we created, find the IP address from Kubernetes, and send it all back. Okay, you guys ready? Let's see if it works. It did before we started. That's all I can say. It is very sensitive. It is like a house of china right now. And it takes a little bit more than a minute, but you have to understand what's going on. In about 60 seconds, I am creating an instance of SQL Server. Okay, not that impressive because we could do it in about 30 seconds with a container. Okay, fine. And that SQL Server instance that I've created on a container, it's totally a container, has 2 databases, about 200 gigs each. So about 400 gigs, all thrown onto an instance of SQL Server in, 90 seconds, a minute and a half? I mean, and by the way, that's mainly the turnaround time going up to the cloud and back, even though we've moved it all to the data center right here nearby because we knew that latency was going to be a pain in the butt because it's all been developed in England. But in a minute and a half, we spun all that up. Don't believe me? Anybody not believe me? Let's take a look at it. So here's my IP address. Copy. Azure Data Studio. Woohoo! paste. We've got to change over to SQL login because it is SQL logins. And I'm logging in as SA. I don't have to. We can make changes to that. But that's just the way the demo is set up. Wait. Got to get this right or things will go very, very wrong and you guys will be way unimpressed. Come on. There it goes. Azure Data Studio thinks I have an instance of SQL Server. But my SQL Data Studio also thinks I have tables with columns and all the rest of that stuff. It is fully queryable, readable, writable database, all created, granted, it's a little slow. It's the internet here. 90 seconds, or give or take. Thank you. Give me your money. Right? I mean, seriously, give me your money. I'm joking. I'm not the sales guy. Clearly, I'm just the nerd. Yeah. Any idea how it would be licensed? No. No, and I don't see a single one of my guys here. That jerks. God, they knew that I was doing this. Anyway, no, I had no idea. We haven't gotten that far yet. We want to get it functional, and then we'll figure out how to sell it. Right now, Clone is sold by not the number of people using it. We want you to make everybody use it. But it's sold by the amount of the size of the images that you're maintaining. So the volume of your images, how many images you need to maintain over time, that's the licensing scheme. I suspect this will be the same because from a container standpoint, you're going to make 1 million of them. We're not going to license it by the instance or anything like that. That's crazy. So I'm sure it'll be similar. But that's just me speculating. Don't start writing down numbers Grant said. Yes.
Can you take a clone based on the security rules? Let's say for different group of developers, taking a clone of a database based on their security rules.
Can you take a clone of a database based on specific security roles of developers? Oh gosh, yeah. You can set it up any way you want to. Yeah. It's all. Extract only the data. No, this works off what I haven't shown. I'm not going to try to demo it real quick. What I haven't shown is the way Clone works. If you want to, I can show you down in the booth, but the way Clone works, you have to create an image. The image is created either from a database or a backup, but it's the whole database or the whole backup. You can manipulate the image, delete data, change data, whatever, as we create it, but once, it's kind of like cloning. Once you create, kind of like containers, once you create the image, it's immutable. The image itself. But the clones that you create from it, similar to containers. It's all, does virtualization sound kind of like it's all doing the same stuff? It's because it is. It works off of that. So it wouldn't extract data or only show data to certain people unless you've got that built into your database itself. Does that answer the question? Thank you. Yeah.
So I have my local container.
Mm-hmm.
Contain data, I download to my machine. Now I have my big database, I'm using SQL Clone.
Right. How do they talk to each other? Great. That's a great question. It's like, well, I've got my container and I've got SQL Clone. How do they talk to each other? And they talk to each other through the same mechanisms. And again, right now we don't have the local container working, although we're real close to it. They talk together with the same mechanisms as that folder thing I mentioned earlier. Yeah. Well, it's not a //. Internally inside of the thing, it looks like a drive. But yeah, it's using the virtualization and making that connection. Yeah. Yes.
Did you write your own storage driver for Docker? That's how it's actually.
I don't know. I'm stupid.
No, I really don't know. He said, did we write our own storage driver for Docker? And I don't have the answer to that. I'm not sure. I know that they've been doing some wild stuff, but I don't know the details. I should have asked that before I started presenting this, huh? Sir?
So two things. First of all, we in our organization, we just applied SQL Clone, which is still SQL
Yeah.
So if anybody here has any questions about SQL Clone or practice, I'm happy to answer however.
Okay, before you ask the second one, let me just repeat that because I'll forget. What he said was he loves Redgate and we're awesome. No. I'm joking. What he said was they've just implemented SQL Clone in their system and set up self-service for their developers. And if anyone would like to ask questions for someone who's not trying to sell you something, he would be happy to give you some information. And then the second question.
Second question is, when's this going to be out?
She asked the same thing. When's it going to be out is probably H1, but maybe H2. Probably. Our development team has heard the message, and they are dedicated to making this work. And we've got a few smart people, so it's going to happen. I'm just so jazzed about it. You cannot imagine. I mean, because he opened my eyes on containers, and it's like born again, hallelujah, right? But then I went back to my company going, this doesn't work, and this doesn't work, and this doesn't work, and, yelling and screaming at them until, and they believe it now, right? And they're getting engaged. You're going to see SQL Monitor supporting containers. You're going to see, and it's going to happen real soon, but we still don't have the schedule from them. You're going to see prompt inside of this. Yeah. Azure Data Studio. It's not there. Don't clap. Jinx it. It's not there yet. Plus, I still need to yell at developers. If you guys are all like, life is wonderful, you won't be helping me yell. But it's coming. It's going to happen. So, I mean, we are pull a Microsoft phrase, we're all in on containers. It is absolutely going to be happening. So it's pretty cool stuff. Schedule-wise, I don't know. Any other questions on this stuff? Or on containers in general? By the way, happy to answer questions about containers in general too. So don't feel like you have to talk Redgate just because that's what we're doing. I got my part across. We've got awesome new technology. Yay. Yeah.
So for DBAs that want to start automating their backup restores for testing, make sure they work.
Sure.
What technology would you kind of steer them towards?
So if you want to automate your backup testing, you want to automate your backup testing right? Yeah. What technology should you be using? I can make two recommendations. I'm going to make a very, very honest recommendation, and then I'm going to make a less than honest recommendation. The very, very honest recommendation is go look at SQL DBA Tools.
Okay.
DBA Tools has got, it's easy.
Okay.
Now I'm going to make the less than honest one.
And that's done with your existing infrastructure?
Yeah. Oh yeah. There's nothing to it. Yeah. You just have to get the PowerShell. You just have to get the DBA Tools PowerShell module that you can install from PowerShell, right? It is open source and free, right? And it is free. They have not created a paid layer for it, and they probably won't ever. I know Dixon and the other guys doing it. It's going to be fine. But yeah, I'd go for that. Now, the less than honest answer. Well, if you create an image with SQL Clone, that actually tests the backup of the process. It's true. It's a fact, but that's a sales thing. God, doesn't that sound horrible? But it's true. It does. It really does. Yes. What's this? With Clone, the restore takes as long as normal? There's something broken then because I've seen 30 and 40 terabyte databases run through Clone in 15 seconds. You might want to talk to the tech team, because that's really, if you're telling me Clone is taking as long to restore as anything else, there's a really huge problem. I'd really want to dive on that. I'm not saying you're wrong. I'm just saying that there's a giant problem. And 1.5 terabyte, no big deal. We're running multi-terabyte stuff through it in 15 seconds. So that's Abby normal, I promise you. Okay, but I'm happy. I'm not the guy who wrote the code, so I can't really help. But I'm happy to get the information and pass it on. I'm more than happy to. But that's really abnormal.
Maybe build on that a little. There's a piece that I'm not quite understanding.
Okay.
If we start with a live production database, how do we get that down to the dev servers? How do we get that?
Oh, okay. So you're starting with a live production database. First off, we can connect to a live production database with Clone. I do not recommend it. And it's not because we're evil or anything, but it's just that's an unsafe step and not necessary. I would recommend you point us to your backup files. You point us to your backup files, we can create an image from the backup file. And then once we got the image, then you create the clones. That's the magic bit. And that's the tax too. Images take as long as a backup. They do. And they're about the same size, actually a little bit bigger, maybe even a lot bigger, depending on the compression you get from your backups. If you compress your backups, we might be a little bit larger. But that's the one tax you have. You kind of have to create one copy of your backup, and then boom, clones, yay. Have you been seeing the restores take just as long as if you were production?
I think that was Bill who said that, who's also part of our organization. I think what's going on, and we can talk about this later, but
Okay.
it's the image creation.
Oh, the image creation is slow.
Yeah.
Oh, yeah. Oh, yeah, yeah. Oh, yeah. Oh, yeah, yeah. Oh, okay. Yeah. The backup, oh, yeah, that's, like the reason I use the word tax is because it's a bloody tax. You're paying a tax. And we all love taxes, right? You pay that tax, and then the clone, yay, cool, okay. Whew, I misunderstood entirely. Oh. Yes. The image, well, it doesn't run restore. Yeah, there's a little trick in there, but it's not, yeah. Yeah, it creates images. Yeah. I would not use it for a backup system. It's not meant to be a backup system. It's meant for development, right? That's what it's for. It's for and testing and all that fun stuff, pre-prod and all the rest. But yeah, it's don't. I joked about making it your backup testing system. It's not. It actually does it though. When it does that, that's actually tests your backup. But don't do that. No. Don't do that. It would be bad. Yes.
Maybe I'm missing something here. I haven't used containers yet. If I take a database, let's say that's 500 gigabytes, bring it into the system, and I create an image, where is the data being stored? The image is tiny to
The image, a container, so a container has no databases in it, unless you make them. You can make them that way, don't, but you can. I did the testing, it's horrible. You can put them in there, but you don't. The container is the executable. Done. Now you can then connect that to a folder locally and do stuff with it there. And then what it's doing is it's storing everything locally, and it's a local storage like you would expect. Yep, it's all on your machine. Yeah, that's exactly it. So what we've done is we've set up the process whereby we create these things called images through Sql Clone, and they're stored on the network someplace. There has to be some central storage. It has to be. Huh? Can be. But no, it doesn't have to be. Just someplace on your system that where everybody can connect. Have to have an image, and then once you can connect to the image, you create clones locally. And the local clone acts like a database, fully queryable, readable, writable, but instead it's just a couple little virtual files pointing to the image.
And any update, let's say like a snapshot database that just stores the original to the side or your changes to the side.
No, if you're going to do that, you would create another. Well, I mean, yeah, if you're making changes down here, they store them down here. All the changes get, as you write a page, the page gets written locally.
Centralized image.
Yes.
If he does an update, that's stored with him, but he still references the original data.
Yeah. Well, no, if he makes a change, what it does is there's like a differential, and so it will read his first and then that second. So like if you're doing like select star from a table, but you've modified one row, it'll pick up that row here, and then all the rest of the data from up here. That updated data lives wherever your container is. In my case, right here, these containers are running in Kubernetes on AWS. And yes, that's where that data lives. But also my images are on AWS right now, so the images are up there too. So right now, this is all this particular example is all cloud-based through Kubernetes. But that's not how it has to work. Is that more clear? Sounds like magic, right? It kind of is, but it's not. It's just the whole it's the magic of the virtualization technologies that the OS provides. Yes.
I was wondering how it would be to get a standard data set and like a persistent volume for Docker and be able to clone that.
Create a standard data set for Docker and then clone that. Yeah, you could do that. Oh, sorry, I did make a standard data set for the clone through Docker and then clone the standard data set. Yeah. Talk to him. There's probably a way to do that, but I couldn't tell you what it is. Sir.
Going back to containers in general,
Yeah.
you talk about the images that create the containers. Can those images live on a shared drive? So you have like one image of
Oh, yeah.
everybody's hitting that to create their containers?
Sure. Yeah, absolutely.
Each dev doesn't need
Yeah, no, they don't have to have an image running locally. You can connect it up. It can be a bit problematic because then you're talking network hopping for all that stuff, but you can do it. Yeah. I probably wouldn't in most cases because containers are small. Just take them local.
Create your own local Git repo and
Yeah.
just reach to that Git repo, Git latest.
Right, yeah.
Everybody in their class.
Oh, and by the way, did I mention with this stuff you can actually version it? Meaning like you can branch databases and then branch the code and I'm not demoing that bit because it breaks frequently. I told you it was fragile. but yeah, this can actually you can actually branch a database now. And I've taught branching and development and all this stuff with databases for years and years and years and years and years. And I mean, I'm serious, 15 years doing this stuff. Before I worked for Redgate, my last company, we were doing deployment automation, branching, and all that fun stuff. And we could not branch databases because you can't branch a database. You can't branch a database. Kubernetes lets us branch a database. It's just so awesome. Yes? I don't like you. I'm not talking to you anymore. Don't talk to him. No. You can't merge the database. Doggone it. Yeah, that would be pretty cool. But at least we can branch them. I mean, God, it's been so long. But yeah, we can't really merge them. But you can't, never mind. I'm not going to. Yeah, Yes, sir. What he said was is if you do the code, you can branch the code in the database, and that's fine. And yeah, we fully support all that stuff, and we're totally into it. But what we can't do is branch data. I keep talking about branching a database. I mean branching the data. We can do that now. You can just say branch, and it creates a second database. Looks just like the first one. But I start modifying this one, it doesn't change this one. Yeah. Oh, I know. I get excited. That's not acting. Ask people who know me. Yeah.
I'll try one more.
Sure, no problem.
Is there a limit to the number of databases per container?
Is there a limit to the number of databases per container? No. I mean, yes. SQL Server limit.
But not a clone limit.
No. SQL Server's limit. Yeah, it just works. It's awesome. It's hard to get your head. Oh, he already left. It's hard to get your head around the way containers work, and I'm throwing at you disk virtualization as well. Read up on it. Read up on both of them. It feels like magic. It is not. It's a pure technical solution, but it changes the way we do everything. Let me get back and finish up here. So for more knowledge, oh God, I forgot to edit this. Last time I gave the container session, I was talking right before Bob Ward. That's not true. Bob Ward's not in the next session. But Pro SQL Server on Linux by Bob Ward, great book. Track down DBA from the cold and his blog. Andrew Prusky, smart guy. He has also helped me with this stuff. And there's this other dude that I don't like anymore. No, Anthony's amazing. Anthony Nocentino from Centino Systems. I've got a direct link to his stuff. And the Docker documentation itself is up here. And then SQL Server on Containers is a fantastic blog. So I would recommend that. The key here is that we're now able to do, in addition to system virtualization, we can now do data virtualization. Well, we will shortly be able to. If you want more, please run down to the Redgate booth. But other than that, I'm going to finish up. This is my contact information if you've got questions after today. I love to help people, so feel free to use this. You've got it. Hopefully that wasn't a bad vendor session. Other than that, I'm done. Thank you.